Hello everybody, it's Mrs. Pound, and we are studying Chapter 10 on Chemical Reactions and Equations from BJU Chemistry's 5th edition. Today we're going to take a look at Section 10.2 on types of reactions, and this is the last video for this chapter, so you will have all the information you need to study for the test. Our objectives today will be to classify a reaction as synthesis, decomposition, combustion, single replacement, or double replacement, predict whether a single replacement or double replacement reaction will occur, and analyze equations for double replacement reactions to write complete and net ionic equations. So first, let's start with our first type of reaction, and it is a synthesis reaction. This is when we combine two or more substances into a single product. So we will have substance A plus substance B yields substance AB that has been chemically combined. So we go from 2 to 1. So an example would be combining a solid magnesium plus gaseous oxygen and getting solid magnesium oxide. And notice the 2's out front because we have to have a balanced equation because of the law of conservation of matter that states that what goes in must come out, both the types of atoms and the numbers. The opposite of a synthesis reaction is a decomposition reaction, and this breaks a single substance down into two or more simple substances. So we start with one substance, AB, perhaps even what we had in the last equation, yields substance A plus substance B. So you see it's the exact opposite. An example is we take calcium carbonate, solid, and we add some heat and it will decompose into calcium oxide, solid, plus gaseous carbon dioxide. Now, the delta should be right more directly over the arrow. There's just some limitations to what I can do on these programs. A combustion reaction is a substance reacts with oxygen and releases energy in the form of heat and light. So oxygen is involved and always heat and light produced. The combustion of hydrocarbons produces carbon dioxide and water. So let's take a look at one of those reactions. An example is taking methane gas, CH4, combining it with oxygen, and we get carbon dioxide and water. And again, this equation is balanced. A single replacement reaction is a reactive element replaces a less reactive element in a compound, often in solution. So we have substance A plus substance BZ yields substance B plus substance AZ. So we start with these just swatch out, they switch places. You could even maybe draw a double arrow between the A and B here to remind you of that. An example is we take solid sodium, we add it to water, and we get aqueous sodium hydroxide and hydrogen gas. And you've seen that before in a video in my class. Now, for this reaction, one helpful thing to see this switching out would be to write this as HOH, because over here we have the OH. And so then you can clearly see that the sodium and the hydrogen switch places. So you can draw a double arrow between the sodium and the hydrogen because they are switching. Now, for our single replacement reactions, we can take a look at the activity series to see if they will react. And this is a table of metals or nonmetals in ranged of order of descending chemical activity. This is table J in your reference tables, and elements toward the bottom of the reactivity series are less reactive because they tend not to lose electrons as easily. So if it's at the bottom and the element that it's supposed to be replacing is above it, the reaction will not happen. But if this is the if it's zinc that we want to replace with, say, nickel, it will happen because it's more reactive. It's up above it in the table. So let's see how this works. So a question I might ask is, will gold react with sodium chloride solution? So we find gold down here, it's at the bottom, and we find sodium up here. Because gold is lower than sodium, there will be no reaction, okay, because gold is below sodium in table J. Another question might be, will zinc react with sulfuric acid? Well, here is the formula for the reaction. We have zinc and hydrogen is what it would replace. So we look for zinc. Zinc is right here. And we look for hydrogen. Zinc is above hydrogen. So yes, it will cause a reaction. Now, using the other side of the table, a question I might ask is, will chlorine gas react with MgBr2, so magnesium bromide? So here's the equation. I see that chlorine and bromine are involved, so chlorine is above bromine, and that's what I want to replace the bromine with. So yes, it will take place because chlorine is more reactive than bromine. Now, let's move on to the last type of reaction, a double replacement reaction. This is when two compounds switch partners. So the general equation is AY plus BZ yields AZ plus BY. So you could have arrows between the two here showing that they are switching, A and B are switching, or between the Y and Z because that's the way it is written. An example is lead nitrate aqueous plus potassium chromate aqueous yields lead chromate, and it would be lead 2, plus potassium nitrate. So this is also lead 2 nitrate. And notice the reactants are aqueous. This reaction occurs if a gas, precipitate, or water are formed. So if the products are both aqueous, it will not happen. A gas, a precipitate, or water have to be one of the products. We use the solubility rules to determine if a precipitate are to form because gas and water are more obvious, but it can be difficult to see if a precipitate forms. So that is table F in your reference tables. And you can see here on the left-hand side, it says ions that form soluble compounds. So all group 1 ions are soluble. So if this is one of the products, we have to see what the other product is, and if it's soluble, it will not form. Ammonium ions are all soluble. Nitrate compounds are all soluble. Acetate, hydrogen carbonate are all soluble. Now, also chlorate. Now, halides and sulfates, many of them are soluble, but here are exceptions. If you have, say, silver, chloride, bromine, or iodide, then they are not soluble. So those are the exceptions. So you have to check these for the exceptions. Now, over here, on the right-hand side, these are all insoluble, okay? These are all insoluble. So carbonates, chromates, phosphates, sulfides, and hydroxides in general are insoluble. However, here are the exceptions. You would have to look at the exceptions to see if it was insoluble. Now for these, we write a complete ionic reaction for the double replacement reactions, or we can. And this is an equation that represents all the substances present during a reaction, the spectator ions, the non-ionic products, and the insoluble precipitates. This is only for reactions in solution, and ionization occurs in an aqueous environment. So this is only if both reactants are aqueous. So I want to write the complete ionic reaction for the double replacement reaction that we looked at above. So to do that, I have to separate the ions. So I separate the lead 2 nitrate by writing Pb2 positive aqueous plus 2 NO3 negative aqueous. Notice I took the 2 from behind it and put it out in front because now I'm counting the number of ions. I'm writing ions separately. Plus 2 potassium ions aqueous plus chromate aqueous. Yields lead 2 chromate solid plus 2 potassium ions plus 2 nitrate ions. Notice if it's aqueous, I broke it up into its ions. If it is a solid, I left it alone. So you break up the aqueous substances into their ions. Now, in this equation, we have something called spectator ions, and that is an ion present on both sides of a complete ionic reaction, and it does not participate in the reaction. So, what I want you to do is to write the equation and cross out the spectator ions. So, I cross out nitrate and potassium because they appear the exact same on both sides of the reaction. Now I can write a net ionic equation, and this shows only the ions that react. It omits or leaves out spectator ions. So the net ionic equation that we're going to write is lead ions plus chromate ion yields lead to chromate. And so these are only the ions that participate in the reaction to form the precipitate. So our objectives for today's video were to classify a reaction as synthesis, decomposition, combustion, single replacement, or double replacement, predict whether a single replacement or double replacement reaction will occur, and to analyze equations for double replacement reactions to write complete and net ionic equations. So don't forget your 5 questions, and this is it for videos for this chapter.